Today we're going to continue to look at Chapter 12. Chapter 12, we're still looking at surface area, but today we're going to focus on circular solids. So when it says circular, well, that means that we're going to be talking about circles. And before spring break, we reviewed circles and area. So here I have a picture of a circle. Notice that there are several things going on in this picture. We've got the center of the circle. Notice from the center to a point on the circle, that would be your radius. If I have this entire segment going through the center and going from point to point, remember that would be the diameter. A radius, if you double it, gives you your diameter. So a couple formulas that's going to be important to remember. Circumference. Circumference is like perimeter. Remember, to find circumference, we're taking pi times diameter or 2 times pi times the radius, because once again, your diameter is 2 times the radius. The formula for area of a circle is pi times the radius squared. So those two formulas are going to be important today. So one of our circular solids that we're going to be looking at are cylinders. So some of the cylinders that you've seen on a probably daily basis would be like a can. Notice that a cylinder is made up of two circles. Those are parallel to each other. Those circles never intersect. Those will be the bases. The shape that connects the bases, if I was to unfold it like I have in the diagram up at the top right, notice how it's like if you peel a label off the can, essentially what you are peeling away is a rectangle. So the sides that form the rectangle, one side's going to represent the height of that cylinder, and the other one is actually gotten from the circumference of the circle. Because remember, your label had to wrap around the circle in order for it to actually fill the can. The other circular solid that we're going to be talking about is a cone. You've seen cones probably pretty often as well. Notice that we are dealing with only one base, but this base will always be a circle. We have something called a lateral edge. Notice that it's forming a point. So from the circle, it's creating a point at the top. That side is a lateral edge, and so it's called the slant height of the cone. So notice that if I was to unfold it, it's made up of the circle, which is that base. And notice that this other portion here is actually a fraction of an even bigger circle. So when I'm talking about trying to create a formula for the surface area of a cylinder, we are going to use the following. Surface area is going to equal 2 times pi times the radius times the height, plus 2 times pi times the radius squared. So anytime I see an R in the formula, we're talking about the radius of the circle. Anytime I see an H, we're talking about the height of the cylinder. So if I look at my picture, either circle, the top or the bottom, if I go from the center to a point on that, that's where your radius is located. Your height is going to be the distance between those two circles. If I want to know how do I find surface area of a cone, well, the formula for that would be pi times the radius squared plus pi times radius times this L. I have it written in cursive so it doesn't look like a 1. But once again, R stands for the radius of our circle. And then this L represents that slant height that I was talking about. Okay, so if I look at my picture, there's only one circle. So from the center of that circle to any point on the circle, that would be our radius. The slant height is the edge of that cone. Technically, there is a height. If I go from the very tip of the cone and I make it perpendicular so it hits then the middle of the circle, that's technically the height of the cone. But notice how nowhere in that surface area formula do I have H. I only want L, which once again is the slant height. So let's look at a couple of examples. It wants us to identify the following from the circular solids. So notice that I'm not specifically asking you for the shape of the base because the base will always be a circle when we're talking about a circular solid. But notice that the height is what is connecting those two bases together. So notice that in this picture, the distance between those two circles would be 6. To find the area of the base, we want, remember, formula for area of a circle is pi r squared. Hopefully we're okay. Within this picture, they are actually giving us our radius of 5. So pi times 5 squared, well, 5 squared is 25, and I have to keep the pi with it. So 25 pi is the area of the base. So remember, our formula to find our total surface area, I want 2 times pi times my radius times the height plus 2 times pi times the radius squared. So notice that in this problem, 2 times pi, we know that r is 5 and the height is 6, plus 2 times, well, notice that pi r squared, that's what I just had us find in that part B. So 25 pi is what I can substitute in for that. Okay, so now if I start calculating, I'm going to multiply the numbers and I'm going to keep it in terms of pi. 2 times 5 times 6. When I multiply that, I'm going to get 60, but then I have to keep the pi with it. If I multiply the next part, so plus 2 times 25, that would be 50, but once again, there's a pi with it. I have to keep that. Both of these numbers are in terms of pi, so we can combine those like terms. 60 plus 50 is 110, but we have to keep the pi with it. In this particular problem, they don't give us any type of units, so I am going to write that it is units squared. Because remember, when we're finding surface area, units are squared. So in this first one, the height is really just 6 units. All right. If I take a look at this next one, notice how we're looking at a cone. So in part A, it's asking for us to identify the slant height. Remember, the slant height is going to be that lateral edge. That is given to us. That would be 6. And once again, they don't give us units, so if you want, you can put units. The area of the base, well, our base is a circle, so pi r squared is going to get us the area of that base. And notice that they are giving us our radius. Our radius is 5. So similar to the last problem, we are going to take pi times 5 squared. 5 squared is 25. So 25 pi would be the area of that base. Remember, our total surface area formula is going to be pi times the radius squared plus pi times the radius times the slant height. Notice that the first half of that we just calculated in part B. So the first half is 25 pi plus pi times my radius. Well, my radius was 5, and then times my slant height. My slant height is 6. Notice that 5 times 6 is 30, and there's still pi with it. These are two like terms because they're both in terms of pi. 25 plus 30 is going to give us 55. There's still pi with it. And once again, if there are no units, but we're talking surface area, then it would be units squared. And that's our answer. And so that's us finding surface area of circular solids.